All right, thank you very much. I hope that everybody had a good break, get refreshed with some coffee and biscuits. So, and we'll get into the next session. So we've actually allotted a lot of time for quality assurance and quality control. So both the before lunch session and also the after lunch session. So we've allocated a lot of time. I'm not sure if we do end up taking all the time, then that's good. If not, what we may do is we may roll into some instead. I am going to confess that the AADC purposely doesn't get much into the quality assurance, quality control aspect of things. So I may not be the best position to be driving the discussion forward, but I think that nevertheless, there's a lot of things to say. Will also note that quality assurance and quality control can happen at stages, because it can happen at the collection phase, it can happen at the storage phase, it can happen in the product development phase, all of these different things. So it's while I say we probably don't take responsibility for some aspects of it, things like checksums, they really are part of quality assurance and quality control, and making sure that you're staying within sane bounds is part of quality assurance and quality control. So I guess to lead into from that perspective, I can start with the Australian example where we do actually through using Open RVDAS and Open VDM, we have visual checks that we provide. We have boundary checks. I think you heard from both Webb and also from Dave Pablo-Cohen the other day about some of the transforms that they have in order to provide alerting. So we do that, and then also in terms of having checksum when we move things off of the ship, we have that as well. But obviously it's a big topic. So I guess I'll open up a little bit and say quality, so QA QC within the different programs. Are people involved with that? Yes, yes. Others? So I'll go to my old familiar, sorry. You're just, this is the I'm disincentivizing people from sitting in the front, aren't I? So
random people at the back there.
yeah, I probably should. Ria, your quality control. No, I won't inflict this on you at the moment. Yeah, Corinne, if you could just get us started off, that'd be great.
Sure. So this is something that actually new vessel we've kind of had an eye on from the start, because since we are not the main consumers of our data, ensuring that we're catching things early as opposed to waiting for a scientist to come back to us a couple of years later, and whether or not they can even do that. So we have a pretty good architecture and plan, but it's not all been implemented yet. But what we've started out with is first creating a very basic QA system in near real time on the ship as the data is being collected, which includes some basic flags that get applied to the data in real time for, like, you know, is there data? Is it within the range of the sensor that you would expect? Is it within the global known ranges for the ocean? And then the last flag we haven't fully implemented yet is, you know, do we have information about the location and seasonality, and are you within some standard deviation of that range? And then combining all those flags and making them available both graphically as well as alerts on the vessel, as well as sending them to me on shore through InfluxDB and Grafana. So that's meant to be kind of this very basic catching these big problems at the time. We also send our meteorological and underway systems to Samos daily, who does a more involved quality assurance. So it's nice to also have an outside organization who can apply that as well. And then we do some limited post-processing, but our group is me, so after the fact to at least review and see if there's file level issues between what was on the ship versus what came off the ship, and ensuring that all the data is there, that all the times we expect are there, and we haven't lost any information, and that things are generally within expected ranges.
Yep. And yes, you reminded me that we do keep some flags in our database, especially related to our Ocean Pack system, because it regularly goes through a refresh cycle. So we do keep note of when those flags end up happening. And that's actually been useful because we've worked with our Bureau of Meteorology, and they're paying a lot of attention. This is a bit of a tension which has started to come up, is that our data center has always been based on, reasonable scientific quality, best effort, but we're now transitioning with the use of the ship into greater operational use of our information, which, while we do have stability, it's never been 24-hour support, ironclad guarantee that it's what it needs to be. So it's been a bit of an interesting evolution for us.
Can I add one thing though?
Yeah.
The comment that you made the other day reminded me though, is that because we have this capability, I wind up getting asked a lot to do things that are more operational in alerting that wouldn't have been in my purview, but sort of is, like noticing that the satellites or the geographic information is drifting, and alerting the officers on board about that, or other information that I can, get to. So there is also like, an interesting push-pull on requests that are a little outside, but at the same time, it is important also to the data accuracy as well in terms of location. So
Yeah, and so I'll back you up on that. There's this sense in the data community that we do want things to be right, and we do want things to be accurate, but there then becomes a weight of expectation, like so an implicit level of quality control. And so maybe there's a need to be explicit about sort of what's supported and what's not supported. And the arguments that I've often had within the higher level is that, well, if you want this level of operational support and you want 24/7 ironclad guarantee, then you need to be supporting, you need to be resourcing the data center appropriately. And so those conversations are still in motion. But that's something to sort of keep in mind, is that this drive towards operations grade accuracy and support. So Stephanie, do you have anything that you want to add from your perspective?
Well, this is an area that we're focusing on and trying to improve, actually. Because right now our process is very manual, so all of our quality control depends on humans, which is bad. So we're looking towards automating more of that now, and with OpenRV does, that becomes a bit easier.
Yeah.
Our previous system, but yeah, so we have the people on board keeping an eye on the data all the time, as much as possible when they're not too busy doing something else. So it's a bit of a worry things can fall through the cracks there. And then we do a pretty comprehensive processing on all of our underway and CTD data, and hydrochemistry, because we do have a hydrochem lab on board as well. So all of that stuff gets pretty thorough post-processing. But yeah, we're looking to automate as much of that as possible, because nobody really likes doing it when a computer could do a better job.
Yes, and they often come in at inconvenient hours, at inconvenient times, and at the same time, I don't think anybody wants to stare at the screen waiting for something that may or may not happen. But I know I don't like to be surprised when somebody says, by the way, everything's down. So you want to get these notifications. But this does lead to another issue that I can talk about, which is you can get the pipeline appearing to work. So by way of explanation, we pipe our meteorological data. It gets collected by OpenRV DAS. This is part of our near real-time stream. So we have a cron job which ends up moving it to our data center, and then it's delivered via GeoServer. But even though it's this pipe, it depends a lot on consistent names. It depends a lot on complete names. And if you're missing things, or if somebody changes a name, you can lose entire fields. And then I get a call from the Bureau of Meteorology saying, your ship's not heading anywhere. Why is that? Or the other interesting thing that ends up happening is that from a technical standpoint, it looks good, but the content of your columns may be all zero. So when you test your systems, it looks like they're fine. So this is the bridge to the quality assurance, quality control, is that the system is operating fine, but your content is not. And zero might be a valid value, but a constant string of zeros where they're all the same is probably likely not going to be there. So this is just an example that it's not just, is your system broken, is your system on, but there's some degree of, you need to know if your content is sane or not. Yes.
Maybe you mentioned that the users are expecting more and higher level of data quality control. Is there any kind of standard so far? I mean, I'm asking a question because I couldn't find it, but is there any kind of a standard description of different quality control level? I could find it for remote sensing, but not for ground-based measurements.
You mean like a level 0, level 1 type thing?
Whatever, yeah. Whatever, if this is a number, if this is a vocabulary or something I describe as is unambiguous, that okay, here I know what it means, I know what happened, what has been done on this data.
No, I don't think there is, or there isn't one I've found that.
Commonly accepted one, no.
You're right, remote sensing has a very well-defined, well, level 1s at least.
And along those lines, in Australia at least, we've started adopting those satellite designations for multi-beam bathymetry. So you have your L0, which is just the data, L1, which is some degree of correction, L2, which is processed into a product. So we've been starting to adopt that.
You have to tweak it like crazy because I mean the L1 is already way too high level for normal ground measurements.
Mm-hmm. Yeah.
And multi-beam, you can do that because it is a remote sense product. To me, it's analogous to satellite imagery.
Yeah, but so we've loosely adopted the terms, but I completely take your point that it's probably something that we would want to think about. And a lot of this comes into, assessments of accuracy and assessments of error, not only in the bathymetry space, but I've seen this as a consistent pattern in IDW where you have some things which will be useful for one community. And so I'll use the bathymetric example of hydrographic grade chart product that will end up in a legal document, safety of life, on all the rest of it. They have a certain quality requirement. But if you are just wanting to know what's down there, a broad assessment of habitat, so that you can do a survey plan, you may not need that level of quality control. So if you were willing to accept greater error, less accuracy, then you would have a much broader potential coverage. And so as we're delivering data, it would be useful to have that level, that assessment, so that people can make the decision, do they want that broader cut, or do they need it to be much more narrow to suit operational needs?
I think specifically needs to be also, you're talking about assessment of accuracy and errors. I think this is much higher level already. I would give an example of air temperature sensors if they are not ventilated. You can be perfectly at 0.2 degrees or 0.2 degree accuracy with something that is 10 degrees too high because it's not ventilated and the condition as such that you have solar heating. And here, I think we need to make the distinction between, we know the sensor is operating correctly, we have checked that the range is correct, but then we don't have physical consistency checks, which is a different question here. So we are very accurate, but totally wrong.
Yeah.
And it's a much higher level to say afterwards you are accurate, and we know here it makes sense. We know we don't have problems such as solar heating, or with remote sensing, it would be okay. You're perfectly measuring lots of clouds when you want to see this is snow or ice or whatever on the ground. And that's why I think we need to have something much more fine-grained before we go into accuracy and errors.
Yep. No, agreed. Yeah, Frank?
Yeah, just maybe for completeness, I mean, I'm not really involved with R2R, but I know a little bit about it. And so they're not on the ship, they're getting the data, but they have a whole suite of quality assurance tests that they run on the data they're getting, and they're putting it out there. I think Webb mentioned one of them for navigation yesterday that used, but I think they do it not for all sensors, but for some, I think gravity magnetics, multi-beam, navigation, CTD or so, where they do a whole range of sets that's like automated in the pipeline.
Yeah, that's posted, they post, you can look up for any platform that they have their quality per cruise or per day, same with the flags. But to answer your question, I also did not find anything, and that's why I started to come up with basically my own system for that kind of level, to at least give us that general sense of kind of on, off, good, bad, reasonable.
Alex?
So the thing that concerns me in the queue, especially the quality assurance sense, is the setup and the installation, the acquisition parameter configuration, because they are the things that can't be retrospectively fixed. The quality control routines, you can run myriads. If you think of a new quality control routine, you can run it against the data, and you can get new flags. If you've got enough documentation, you can add sensor metadata that might assure people. Those things can be retrospectively added. But if you install or configure or operate the instrument incorrectly, then that you cannot go back. So the time that I've spent, lots of that has been spent on trying to configure instruments and sensors correctly, along with other domain experts. I'm not an expert in all the sensors we have on the vessel. I deal with the data that comes out the end of it, but I realised that QC is part of the wider remit of the data manager. So working with engineers like Dave and his team and scientists who are on there, but always my fear is that when actual analysis gets done, that people will say, actually, we thought it was a good idea, but if we looked at it earlier, we'd have told you that is not the best way to set things. And that's what, with a new vessel, you spend a lot of your time doing, because clearly you're setting it up for the first time. But I am positive that there are some big intrinsic issues. We have a science mast that has half of our MET sensors on, and we have a foremast, which is obviously right to the vessel. There is a discrepancy between the obvious parameters like temperature. The science mast is sat within meters of the superstructure of the vessel at the top. It clearly is being the environment there is different from the foremast, and clearly they need to be moved. But that's a big decision to be made. And we're already coming up to funded science. It's only now that the Met guys here are probably getting involved, going, actually, now I've got a bit of time. Yeah, clearly it's not great to have your temperature, humidity sensors so close to a warming piece of metal.
Yeah, and there's physical configuration as well as software configuration, which may end up changing. And something else which I was thinking about is, I don't know if this would be part of configuration, but calibration as well.
Absolutely. So that's the operational side of it. Is it being operated correctly? You've got an uncontaminated seawater system, but how is that actually operating? You've got sensible values, everything would check out, but and not just sensor cals, as in sending the sensor off to be calibrated, because most people have got cycles of that work correctly.
Mhm.
But in cruise calibration, so you're actually calibrating values you're getting against other values. Either you've got multiple sensors or you're taking a different sensor. So a good example from one of the, I mean, it may well affect us down the line, but one of the other NERC vessels is, for years they ran their temperature sensor from the surface water, and everyone was perfectly happy with it until they did some in-depth analysis and worked out that actually it was several degrees wrong. And they realized at that point, when they went back to the design of the ship, that the pipe runs through an uninsulated space, an engine space.
Mhm.
And this was
Warms it, yeah.
years, I'm going to say a decade after it came in, that they realized that, you know, for that entire time, the water coming in, by the time it got to the sensor, was warmed, which they obviously retrospectively dealt with. But
Mhm.
that's the kind of thing that I fear more than the quality control that you could add on afterwards.
Yeah. Well, and I think that this is part of the broad discussion, is that, yes, the quality control does in fact creep in, well, not creep in, but it's applicable at many stages during the process. And so this then does open up, you know, we've been talking to our usual suspects of sort of ship collectors as well. But what this does mean is that, because it's not just at the collection phase, quality assurance and quality control affects all of us as data managers. So I am actually going to expand a little bit further around the room now and say, what are people's quality assurance and quality control concerns at whatever stage of the pipeline that you're at? So I'll probably put you on the spot. Helen, what would you sort of add in terms of, from your perspective as a data manager, in terms of quality assurance, quality control considerations at wherever in the pipeline?
I don't think I'm the best person to put on the spot.
Don't have to
on
be the
this,
best
but
person.
it's the sort of thing that I leave my data managers to worry
Okay,
about.
all right. Alice, you've been dumped into it.
Yeah, so first, like on the ship, I will support what Alex was saying, especially because at the moment the ship has been mostly used by data managers and we didn't have that many scientists before.
Mhm.
So we are really, like for some instruments, we have been sometimes the only one using the instruments.
Mhm.
And so sometimes it's not our like main domain, so
Yeah.
we don't really know how to interpret things.
Mhm.
And so having information from scientists to say whether it's good or not is difficult because they were not on board and it was not at the, like it's not at the top of their priority.
Mhm.
But
Yeah.
it will be the key things later on. So at the moment, I think because the ship is so new, the first cruise will be like in a couple of months now, like 1 month. So it will be the real test just now, while we have been trialing the ship for so long. So that will be the first test. Then for quality, yeah, I think it will be also when the first analysis will be done that we will have first real input to know what to do.
But you touched on an interesting point about sort of the engagement with the scientists in the process, because there is that time factor as well. But this is something that I've run into in the AADC, is that it's impossible for us to cover all of the range of sensors and to be an expert in ice wave radar, to be an expert in all of these different pieces of kit. So we can't really know what it is that we need to be looking for. And some things may be contextually dependent as well. Like it may make sense for a temperature to be running at 15 degrees, but it may not make sense for it to be 15 degrees if you're in the middle of a blizzard and you're measuring seawater temperature. So I don't have an answer, but I am just sort of I am highlighting that point that the engagement of the scientists is important, and it may not be something that is quite so easily automated. So you would then say, is the answer to have, scientists always aboard the ships and always there? That's good in principle, probably not in reality. So do you instead turn towards AI, try and, artificially do it all? I don't think that that's probably likely in the short term either. So, I think what you start to get into is a little bit more the notion of how do you get them remotely involved? How do you provide the information so that, they can do reality checks on things and probably not be staring at a screen, but have sanity, like wide boundary sanity checks. And then if something looks suspicious, that's sort of a yellow flag, then have the ability to remote support it and then get a red flag. Does that sound like a sane approach, or does that sound like a silly approach?
No, we add also that on the ship, we have so many sensors. So we have either the sensors that are collecting the same information. And so sometimes we have so many information, but that can be contradictory. So then you're like, oh, why is that? Why, and it's touch on what
And which
Alex
one
was
is-
saying, which one is the best one?
Yeah, which one do you believe?
What is the temperature then outside? Oh, this sensor says it's 12 degrees, this one 10, and this one.
Yeah, and you look at
11.
your little glass thermometer. Yeah, do you?
So there is this, and then on the contrary, you have the sensors that are alone, and so then it's difficult also to know. So is it really giving the right information? Because we have no way to really say, oh.
Yeah, you have an N of 1, there's
Yeah.
nothing to
there is
compare
nothing
to.
compare to. So there is kind of the two extreme.
Mhm.
And so it's funny because when you have too many, then there is no proof.
Yeah,
And when you have just one, is it really the proof?
yeah.
So
And it's hard to ask the government to fund 5 ice wave radars just so that you can check them against one another.
Yeah, and that's why you need in cruise calibration. You need some ability to, but that's difficult to do when it's not a science cruise, especially on logistics like things like that. Or when you do have a science cruise, but it's not the main purpose of the cruise. It's one thing saying it should be done.
And so, I mean, it sort of, I think probably gets back to your point of, do we have some way of describing the sort of condition, and I take your point, not just accuracy and error, but like the sort of the predicted uncertainty. I don't know what you would call it.
The effort.
Yeah.
So on that, we tied ourselves up in knots to the support teams about what service level we were going to provide on board the vessel. And this is tied very much into QA/QC because the end point of the service level is quality, data quality.
Yeah.
For the provision of support.
Some level of assurance and reducing people's uncertainty about the data.
Yes, but we found it incredibly difficult to articulate the factors that were involved in that. Although unilaterally I did write a document which everyone read and went, there's no way, that's too much information. So we dismissed it. I still have that document about how you would do that on a per sensor basis. About how you could think of different service levels and what would affect the ability to provide those levels and the elements between them, which might be at least useful information.
But in defense of your document, you sometimes.
Seen it yet?
No, but the concept of it, in defense of the concept of your document, you often run into this in legal circles where you sort of read it right up until the point that you then need it. And when you need it, you're glad that you have it. So, people may not be interested in that level of detail 95% of the time, but then when people run into a situation that needs to be resolved, then they need that level of detail, and if it's been provided up front, sometimes it can be good. Granted, I haven't read it. I may change my opinion once I've read it, but I think my point here is that having these, they're probably dry and uninteresting to most people, but sometimes having these standards, having these things that provide structure can be incredibly useful down the line. So I'm going to, I'm not trying to make effort, but I am really trying to tease out that, you know, it's not just about the ship collectors here. Quality assurance is something that should be important to everyone here. So what does quality assurance mean to you? What would you like to see? Yeah, Nils.
So on the vessel, we have some basic checks.
Yes.
I'm not really involved in those.
Yeah.
And part of the data is every 10 minutes published on a sensor instance. And there I started, for that instance, I started writing some scripts to do some quality control. Initially, my first issues were to what level do I check? So initial checks are, is the point actually in the sea or not? I can also see where, so then if I then check salinity, do I check only for that sea region? Do I check general? And when do I put if it's all within the ranges, when do I dare to put the flag on it's good?
Mm-hmm. How much checking is
My
enough?
colleagues are saying I'm too careful because I never put a flag it was good. Always it's probably good.
Mhm.
So there's always a check I didn't do. So there had an issue. What do I do here?
Yeah.
And even the checks are very basic because I don't even know where the sensors are installed, so it doesn't take care how it's installed, if it's calibrated or not. That's all not yet included in the check. Water surface.
Mhm.
If the flow level is too low, I also put flags on the dependent sensors
Mhm.
results. But I keep always, all the data is always available to the sensor things, even if it's bad. So then I still let the end user decide if he uses the data or not.
Yeah.
But then you assume that the end user has some knowledge about how to interpret
Yeah.
the flags.
And sometimes the end users will say, you know better than me. So even if you're not certain, your uncertain is better than my certain. And so you can put. We probably won't get to a level of having a percentile. Might need binary checks, or you can say, I've seen this in some systems where you have a categorical, my assessment is A, B, C, D, E, but in the end, it's sort of expert valuation. And, often I run into this in other circumstances where people will say, I don't expect it to be perfect, or I don't expect it to be, I'm not going to sue you if this goes off. I just want to know your best effort. But where this does get complicated, though, is this ties in with that operational creep that we talked about before, because you say, well, I'll give you my best assessment. I think it's good. But then you get people leaning on it for a purpose for which it wasn't intended. But in that case, I would say the onus is on the people using it for a purpose for which it was never intended. If they wanted to use it in an ironclad way, then they need to be explicit about that.
We're also doing a small project with university where they compare underway data with data from fixed locations and see what the difference there is and how it evolves over time. And we initially saw that if the temperatures were generally very low, then the difference between the two systems became bigger. And that's only what we saw in the first weeks of the project. So now we're looking into how we can extend it and how we can know what's actually causing this.
Yep. You're also making me think about sort of the the effort versus certainty type plot. And in the end, you may need to talk with whoever your users are to sort of say, well, how much is it worth to you? You know, what's that differential in terms of certainty? You know, in order to expend that much more effort, you have to spend that much more time, you need that much more people. And that comes at a trade-off for programs, it comes at a trade-off for resources. Are you willing to accept that decrease in certainty or that decrease in assurance to say, it's all right? I don't have an answer, but I think we're talking about the issue of trying to provide some sort of assessment of confidence. Quantitative would be great, but might have to just be qualitative. And you say, well, if this is insufficient for your purposes, then we would need to revisit it. Sorry, yeah, Taco.
Well, first I would like to point you all to the Ocean Best Practices website, oceanbestpractices.org, which contains a very long list of all kind of manuals and guides on all aspects of measuring in the ocean, including many guides and manuals on quality control, assurance. So that's a first step that I would everybody advise to search relevant information in the Ocean Best Practices portal for them. And back to your question on what we are doing, on our ship we have an officer dedicated to maintaining the electronics and the sensors on board the ship. So those people are eyes to see if something is happening with the sensors and if something goes wrong with the measurements. And that works very fine. But I'm not entirely certain that it will also work if you have a sensor which is slowly drifting. They would notice those changes. I mean, they can notice, of course, the real errors. But if there is a slow drift, I have my questions about that. And part of the sensor output, especially the meteorological sensors on board, these data are sent to the Met Office in the Netherlands, and they check all those data. So that's we're pretty sure about the quality of the data. And that's checked externally. Another aspect is that, for instance, the CTD being operated by the scientists on board, but the scientists on board, often students sitting there during a cruise, it may be their very first cruise, and the scientist may have one cruise a year or one cruise every 2 years. So that's also not very, it's not a very certain way of having quality control of data coming from the CTD, because the people often lack experience in interpreting the quality of data.
So there may be an aspect of human configuration in it as well, because you would say that if you have the same human operating it day after day, year after year, you would expect more consistency. But if you have different humans with different levels of training, then that may be worth representing. Yeah.
And that's not about whether it works or not, because that's easy to find out.
Yeah.
But if you have slow drift in sensors, or if you have slight faults in the sensors, then you would not notice that.
So something, go ahead, Frank.
Just directly response, and sometimes it's also the opposite. I mean, I've been on oceanography cruises, where it's actually a scientist who then, if they're interested in CDD data, they take water samples and do, discrete salinity tests, salinometer like analysis and checking for the drifts. And I mean, sometimes maybe there is they have to correspond back to the operators on the ship and saying, okay, we see a very strong drift or not, but sometimes they just keep the data and then they later on back in the office they do the corrections. But if you don't have those scientists on the board who do actually run this salinity tests or oxygen tests in the labs, and you might not get this calibration during the cruise.
So both of those are examples of in-cruise calibration. Both salinity and oxygen, direct sampling and taking them off to another more accurate, you assume, more consistent piece of analytical kit, which you then feed back to you. Effectively, you're underway, although it is just deployment data to fix that. And that is some of the stuff that I write in the service level. Is that the higher end of the service levels, that would be, CT is a good example. You would have that in there, but we would need to know that somebody would have to run those, and by default, our support teams don't have the time nor possibly the expertise to run those. So in your highest levels of service, your higher service levels, you actually require the cruise party needs to know they need to bring someone with them.
Yeah.
They need to do something about that to get the highest level of quality assurance. And most researchers know that implicitly because that's their domain. They know that if you're an oceanographer, you have to run salinity samples, and that's what you've been trained right from the start to do.
So given that in situ calibration is an important thing to be keeping track of, is there any issue in representing that, or would we just say, look, this is an important thing that we would need to keep track of some formalized way?
But so that's why in your service levels are grandiose terms, but let's say it's almost your operating procedures. As you can say, yes, we could launch a CTD, we could give you a profile. And if you're a non-domain expert, you can take that. But you need to know that this will only get you this level of quality assurance for that, because there will be sensor drift, which you will not capture. And you have to accept that. If that's how you're going to get that data, that needs to, and there needs to be something in the data that if it goes then beyond, clearly, once you make it available beyond that, people who weren't on the cruise, who didn't make that decision as to the level that it was acquired at, need to know that level so they can make a judgment on how they're going to reuse it.
It's like a quality assurance menu for a particular thing. So like levels, but you would say you can choose menu course A, menu course B, or menu course C.
Yep.
Menu course A will cost you $10, menu course B will cost you 20, and menu course C will be 50.
Possibly, even if it's not direct money, you need to bring people.
But I would just sort of have it in the sense of, resourcing, but you get this out of it. And you may be able to represent that as sort of a combination of activities or accuracies or measurements or what have you. But I'm just, again, thinking about this out loud as a way of representing that service level as sort of a quality assurance level of expectation.
Okay. And we would like, obviously, as a support for science, to be on the far end. We'd like to have gold standards for everything, but that is not feasible. You can't run every sensor at gold standard. Take your multi-beam, you cannot run it at a hydrographic standard and do all the other things that are needed.
Don't have the time, don't have the money, don't have the ships. So yes, I think that in terms of representing it, you could represent it as a service level, which is a composite. And then separate to that, you would be able to represent the level of resourcing required, which would be the larger sort of organizational discussion. Another thought that I had as we were talking before, and again, if other people have points, feel free to chime in. I've run in this notion of who is doing things, and I often think of sort of using ORCID to keep track of who is doing things. But this does lead to a potential touch point that we were talking about in IDW of privacy levels. So anytime you start introducing who, you run the issue that, you know, if I say Joe Bloggs was responsible for this, you may be able to pull out, well, Joe Bloggs was doing this, and I guess my point here is that at what level do we need to, if we're going to be capturing the who aspect because we think that it's important, at what level does that start to conflict with people's privacy as part of an organization? It couldn't just be assumed that because you're part of an organization that you go through. So you may need to, I don't know, possibly notify people that they're going to be included as part of a data set. Any thoughts on that? Yeah, Petra.
I had recently a discussion with a colleague of mine who is taking care of these things within a bus, because we are trying to introduce new portal and it has information about scientists who took part in individual cruises, but it also has information on the crew that has taken part in those cruises. And the question was, what information can we release? Because if we say that this person was at this time at this place, this is actually processing personal information.
Yes.
So that is a then question, what can be exposed? And essentially, conclusion from that was that because scientists produce reports which are publicly available, so that information is already in a public domain, and B, it can enhance their career, so that it is in their own interest to have that information available on the portal. We can expose information about what scientists did what, because it's also part of the cruise report, as I mentioned. But we deliberately don't provide information on the crew because there is no incentive for the crews to have that information publicly.
And you don't provide that information, but would you maintain that information? Because even by maintaining it, you'll be keeping it. And because part of the argument that I'm going to start to get into is that, yeah, I can see that that's fair for the scientists, but as we've seen, there's this interface between the technicians who may be doing the calibration and the gear officers who may be responsible for maintaining it. So you may need to keep it, and even in the act of keeping it, that runs a risk of, well, it's their personal information, and did they agree to it? You know, or is it just implicit that, well, you're working for the organization and it's okay?
Well, we do keep information on who is doing what, who was technician, who was scientist, who was a crew, who was captain. But that is part of the internal database that is not the only bit that is being made public.
So it would be considered, so it would probably be something that would be maintained, but would need to be maintained as private information.
So we keep it internally, but don't expose that to the.
Yeah, it would be private.
Although that information is in almost every cruise report I've ever seen, has got a listing of the crew, so it already is public information.
But going forward, actually, the advice was that going forward, we should, in principle, ask everyone for consent that we can do that.
And I'll use this opportunity to tell a little bit of an anecdote from International Data Week that was a little bit of an illustrative case. You were talking about, you know, sort of unintended consequences of making personal information available. Some of you, at least in the data world, may have seen the New York City taxi cabs data set, where they talk about where it started and where it ended, and they have the path and fare. People started to, so the people that released that thought that they were doing a good thing, used for big data analyses, examples, all the rest of it. Quite good, anonymized. But people started to then abuse it because they would focus on gentlemen's clubs and see the drop-off point, and then they would backtrack it to where people came from. They also started to reverse engineer particular cabs and how much money that they ended up making, and then they were able to infer how much that cab driver was using or was making over the course of the year. And so the reason that I bring this up is that they release this data with good intention, but the possibility does exist that people can then say, oh, well, Joe Blogs goes off to Antarctica, you know, every now and again. Well, I can use this to my advantage, you know, maybe, you know, do some spending on his account. I'm being hypothetical, but it's, my main point is here to say, you do, while it seems innocent to say, oh, well, people's names are in there and it'll be fine, the potential, the unforeseen potential does exist for abuse. Yes.
I go a little bit further with that and say, especially when working with Indigenous people, it is to the extreme, let's put it that way, in that, I mean, that's really why care practices came in as a complement to FAIR, but also why on one of the projects that I work on, which is exclusively with Indigenous communities, it's ownership, control, access, and possession protocols, care principles, and then all of the protocols of that specific nation, and then all of the protocols of that specific community. And it has a lot to do with how Indigenous knowledge is collectively held as opposed to it being individually held. So even when I did my dissertation, there was one person who is probably the most knowledgeable person in that entire community about the topic that I was talking about, and did not want to be named, because that is the way traditionally that he was taught, is this is everybody's information, don't say that I said it, because I'm not an authority, everybody's an authority. And that has to do with the law that they follow. And this, so when we start talking about those types of things, which hopefully we will start talking about those in more detail. Like I said, it's a whole other aspect, because traditionally academia and science has not been very good at respecting the wishes of who's involved, but also because we've been very extractive. Yeah, Karen's like,
I
so
can't deny.
there's, and I think that in a way I'm lucky, because I work with very specific group of people who are all from the same nation. When we start talking about people that are from different nations, but also when you start talking about the difference between quantitative, qualitative, social science data, there are different rules that apply. And I think that we're moving into kind of a better understanding of our responsibilities when it comes to those types of things, because of the mistakes. And it shouldn't be that way. It shouldn't be, we have to revise because we've made a massive mistake that's harmful to people. So it's taken, I think it's taken a lot of us a long time to figure out what that looks like. I don't know, Karen, you could probably talk about it. But I mean, just on our side, getting through ethics was a nightmare, because the university is set up in one way that isn't necessarily conducive to working with people who work in an entirely different way.
Yeah, please.
So the OCAP, the ownership, control, access, and possession that Rebecca just mentioned is something that's specific only to one of the three categories of constitutionally defined peoples in Canada, that is First Nations or #Indians. But there's also another, the Royal Commission on Aboriginal Peoples, completed in 1996, I think, or I'm gonna say 6, has an entire section on ethics and research that nobody has implemented. I know I did in my own research, and in terms of institutional ethics, that is 100% bullshit, because institutional ethics are about a legal protection for the institution. It does not guide any ethical engagement with anybody in your research. And so the institutional ethics, I believe, are morally bankrupt. There's no accountability to something. A researcher came into my own community and extracted all of the artifacts that they could find, the physical artifacts, and she fucked off with them. And nothing happened. Oh, she's a little bitch. I'll tell you about her later. And I say these words strongly because nothing happens. And yet we've lost all of our artifacts that she could find for her own PhD. And she's now a professor teaching her own crap. Like, this is a big deal. And I'm just so frustrated with it, obviously. But when we think
No, but
about
that's-
the
but we
good,
need to hear that.
the relationships that I need to have is like, and it's never, and there's this contradiction in English, which is the only language I know, is the individualism of research and the collective knowledge that individuals hold, which even though this person, I'm gonna call him Joe, because that's a good name. We can say that Joe knows something on Thursday or today, October 31st, but as he's walking around, he's gonna say, oh, I didn't realize that was actually the color blue. I only saw it and I thought it was green, but because it's written down, it's now blue. And in fact, Joe, 3 days later said, oh dear, I made a mistake about that, but it's done.
That's not even talking about situations where, you know, for example, one of these fun things, the example that I use when I'm teaching introductory linguistics is that some languages don't actually have colors. You use X is the same shade as Y. It's a construction, it's not a word. So even in Ganyak Geha, in Mohawk, there is no word for black. It's dark. You can say something is Hongji, but it's not, it doesn't mean black. But it also covers things like the sky at night. So there's not really that aspect of midnight blue. It's just dark. So one of the things that I'm hoping that we can have a conversation about is how everything is a symbol. Everything is a symbol. And I think if we're staying inside of our understanding of what a symbol is, according to however we were raised with symbols, then we're doing a disservice not just to us and to others, but also to anybody who in the future is planning on trying to use some of what we're doing. But I'm also a semioticist, so.
No, thank you. Yeah, I'll go over to you. Joyce, I'm going to just sort of say from bringing it back to the quality assurance and quality control discussion, sort of the path, the fork that led to all of that was the notion of we do need to be careful. So representations of who are doing things for quality control are important. But if we start representing who in the quality control, you do also have to be mindful of privacy and ethics and all of these sorts of things. So I think that's what I would say on that point. Ria?
I don't want to say much because I'm talking on whatever a lot about this, but within the SCAR policy, there's specifically regarding humanities and humans, certain policies exactly to cover this thing of the humans that you don't abuse. There's certain things that's written in the data policy that all of us in SCADM knows, but I'll talk about it rather on Thursday. I don't want to. So I think it is very important. Doing with the quality control, including with that.
Yeah. So there are many dimensions to the quality control, not just the technical aspects, but you might also say that treating your data in an ethical way is also part of quality assurance and quality control. Assurance that you're going to do the right thing with it and manage it in an appropriate way.
Perhaps,
Yep.
I'm struggling a little bit with all of what's said, because to be on the safe side, you should probably, I think if we ask a lawyer how to do this, they should probably say, never keep any names, etc. But we're talking about quality control. Suppose you're using data which you got through, I don't know, Suez map or something like that. You find an issue with the data. Then you report back and you get the name of the, or you find it in the data set of the scientist involved. And you contact that scientist, and it turns out that there is a difference in the way the water samples had been filtrated. And it turns out that that scientist needs to ask the technician who did the filtration how that can result in different values and
Maybe they were using a different procedure.
So then you need to know, at least internally, to keep the name of that technician involved as well. And it would be, for pure quality control, it would be disastrous if we would get rid of those names as well. Because we are afraid of some.
And I don't think, at least that wasn't the argument that I was looking to make. And I'll also add, there are positive benefits as well in terms of attribution and understanding, because it's not always just a scientific publication. There is work that is being done by technicians and electronics officers, and it's good to represent that as well. But I think that the harmony behind this is that I do think that it's important to keep track of who, but in keeping track of who, that does introduce, you have to think about how you're handling privacy and access to the who. So I think you can't be careless with your who information. You have to be a little bit more aware of what you're doing with it. But I would certainly say it's important to keep track of the information, but yeah, don't be careless with it.
Don't be careless towards the outside world.
Yes. Well,
because you should probably keep it internally so that.
Yeah, but I would say making sure that it stays internally is part of being careful. Because if you just say, well, send it anywhere and it ends up being exposed, then that's when you could potentially cause trouble. Yes.
So, yeah, I agree with what you're saying, and I think like as a basic rule, so our data centers at a university, which also means that we're guided by the governing principles of the university, which are in turn guided by the province we're in, as well as the government of Canada. So every personal information is protected under that auspice, and but our data center is open by default. So we have data sharing agreements where if you're a researcher, you're putting your data in, you know your data is open, you've chosen that option. You can choose to make it private, but as our core metadata, for example, there's always a data curator and there's always a key principal investigator so that there is that contact information. And then if the other information is not public, it's still held behind the scenes in our records. But I've also worked with a lot of NGOs where guidance can be a little more confusing because they're not governed by strict regulations in terms of university policy, for example. But they are still, I mean, anybody in any country has to follow the rules of that country for data privacy. And in fact, our data center follows the EU data privacy policies because we found them. Eventually Canada catches up and we find the EU policies are a higher standard. So we didn't want to have to play catch up at the end of the day. And those are very good, very clear policies in some sense that this is considered private information, like personal information.
Yep.
And the basic rule of thumb is you only make public what absolutely has to be made public. So for example, in the case of a vessel where you've got ship's crew, their names might be on the rosters, but their personal information, there are guidelines that already say you have to store this information in such a way. So personal information by people that you're paying, if you're an NGO, can only be stored for a certain number of years after that person is no longer working for you. It has to be stored if it's a hard copy in a locked container that only certain people have access to. So that's the general guiding rules that we use in those kind of cases that protect us in case there are people that come back and ask questions, and we still have that information. So we can use it.
And I think there also might be an aspect of informed consent. So if you talk with the crew and say, "Do you mind if we sort of associate you with the project and, you know, with the intent of giving you credit for it," some people may say yes, but you're at least giving them the choice in the matter. So that may be another possibility. Sorry if that was a little bit of an unintended rabbit hole, but I think it's probably important to keep in mind. Other aspects of quality assurance and quality control that people would be interested in talking about? Yes, Masaki, please.
My question is, I'm deputy environmental scientist, or I'm chiefly involved in the not the ocean, continental area for geophysical observation instrument. But in my recognition, such kinds of geophysical instruments belong to the regional or global network. So the quality control has been the consensus of in a global average standard, seismology, gravity, and magnetism. And also in my recognition, the continental part in Antarctica, there is a project of SCAR, such as ATOMAP, magnetic map, and EDOMAP, radar echo sounder. So in that concern, are there any consensus of the data quality, such as in SUS or sub-task group underneath SUS? Are there anything or nothing?
I don't,
in my question.
I don't know if there's anything by SUS.
SUS or related research project or database group of the SCAR.
Yeah, I don't know enough about it to be able to say, I'm afraid.
Can I fully understanding the question? What was the question?
Are there any consensus of the data quality control of the SUS group or subgroup of the SUS?
Like, are there sort of benchmarks for quality at the continental scale?
Oh, the data that's streaming into the SUS are from individual providers who have their own data quality control. So these data sets are already published, usually by the origin, the primary provider who is assuring the data quality. And SUS doesn't have the expertise or any board that would decide what is a good quality and what is not. So the data sets are coming from the community as a that has advisory board, but on a level of content, what type of data set should go in, but not what the quality of the data set should be. That is something that is guaranteed by the providers. So there is not like a checklist, if you mean something like that.
But one thing that might be possible is, as a large collection of observations, people might be able to look at it for a distribution of likely values, so that the collection of larger values might be able to be used to inform where, you know, a likelihood of where you would expect to find certain values. That might be an option. Frank?
Yeah, maybe tying back to the vocabulary discussed earlier, it might be good to have a common like standard again, or something where we say, okay, if we have different quality control levels, like how do we name them, and you know, in terms of interoperability, that we know, do we using like level 1, 2, 3, or you know, good, bad, or
sort of a standard way of
so people said, oh, I only want, you know, everything that's like CTT data that are fully calibrated, or you know, or I don't care about those, they take everything raw data. So I mean,
and putting together a proposal for, this is what we as a group propose on agreeing to name things, that might be start, even if we, you know, leverage stuff, but sort of there, I guess that there's a potential work package to say these are the labels that we're going to put on these things. Okay.
I guess there are lots of flagging systems that the ocean best practices, so we're following the IODE and the World Oceans ones. So we do use those flagging systems on our data.
Yeah. So maybe worth reviewing those.
That was gonna be one of my questions, so they are the flagging vocabs that you use.
Yeah, so there's a flag, the IODE standard flags. I think it's only a 10 flag system, like no data, bad data.
Yeah.
What they all are, but
Bad-ish data.
And do they have criteria for those, or is that the subjective assessment we were talking about earlier?
I'm not sure how, I think there is some criteria.
Some criteria for it?
I think it's actually part of the NERC, it's included in the NERC vocabularies.
Okay.
Just goddamn.
Good to know.
It's referenced, so I was looking this up, it is referenced in one of their vocabs, they have a vocab that describes the vocab. So it's unclear whether they actually keep the vocabulary itself, they just have a row that says there is an IODE vocab, because BODC run their own internal, which I don't think is publicly available. It's named, but I don't think you can see a public view of it, which is their own internal flagging system, which is about, have they run out of letters? I think they might have done. It's about 25 codes, which have all the ones you would assume from your IODE plus a whole bunch of other ones. The last time I saw it becomes a bit of a mess. Because you know, people have them in for specific purposes and they don't quite fit generic flagging.
There are at least 10, I think maybe 15 different quality flagging systems.
Well, and in the BODC list, they've got
An IOD being one of them, CDataNet, UDC.
Yeah, they've got 16 listed.
Yeah.
But that's just BODC tracking. I mean, I'm sure there are other ones out there. If you look hard enough, you'll find. And there'll be absolutely loads of internal
Okay.
flagging systems that people, because everyone comes up with the same thing, well, we need some codes.
Yeah. And collective agreement on it. So I think one thing that may be useful for us to do is to review what's there, and put together a straw man of this is what we would propose as our pick, our pick of things. Let's propose a system. And if people like it, good. If they don't, then they can pick at it. But I think that this is probably something that we can impose on ourselves as a community is let's put together a proposal and try and establish it as a convention. Okay. I'm probably going to use that as it's almost 12 o'clock, time for lunch. So that seems like a logical place to pause and break. Again, I hope that people have been getting value from this. We certainly had a lot of good discussion, and I feel that there was very good representation throughout the room. So, but if you'd like to see more of something, let me know. If you'd like to see less of something, let me know. But we'll continue in an hour. What I'll probably do is we'll see if there's any more that we would like to discuss on quality assurance and quality control. But if not, then we'll move into some of our other topics. We'll just go straight into. Okay. All right. Thank you, everybody. Bon appetit, and we'll see you in an hour.